Okay, thank you very much. As we said, we must make sure we score our distinctions in each of our papers so that we are sure of our A's. And then today, as Mr. Kaziba has put it, we want to look at, to revise vectors. We already have very good ideas of vectors. Now, someone has already posted in the chat, we do not have the questions because the seminar questions, etc. I chose some questions, some from the QB, the question bank, UNEP, and from other mocks. And I expect that if you have some, you are going also to share with us. So I chose some questions. We can look at some of those. Some are as short as 5 marks, section A questions. Others are the section B questions. But then if you have yours also, prepare them so that we can also work together. You can also share with us and then we work together. Let me take you straight away to the first question that I chose from UNEP, a section A question first and foremost. That is our first question, just 5 marks. Like we know, vectors is, we shall have a purely vector question in section A and one other one in section B. And because we are revising, I've not put them in order that we start with a line, we can handle anything at this time. So our first question is that, can I have a volunteer to read? You are seeing the question. Can I have a volunteer to read it?
Two documents are in queue.
Someone ready to read for us? I want also to find out if you're seeing. It's important.
The question reads.
Someone ready? Chris Peters, go ahead.
Yes. Okay. The question reads, given the plane 4x plus 3y minus 3z minus 4 equals to 0, question A, part A, rather, show that the plane A in, show that the plane A, then the vector is 1, 1, 1, lies on the plane. Show that the point A,
Peters,
1, 1, 1, lies on the plane.
The point, thank you. Show that the point A. Go, continue, please.
Then part B, find the perpendicular distance from the plane to the point B, 1, 5, 1.
Thank you very much, Peters. Now each one of us can read through the question again and try to internalize it and try to interpret it. And then I'm waiting in a short while to give me what you expect us to do in this case. Okay, what are we going to do in this case? The first part requires us to show that the point A, whose coordinates are 1, 1, 1, lies in the plane 4x plus 3y minus 3z minus 4 is 0. How would you show that a point lies in a plane? How do you show that a point lies on a line? The idea is the same. So how do we show that our line goes through a particular given point? And how do we show that a certain point is in a plane? Yes, please. Can I have volunteers on this? Chris Peters, what should we do?
Okay, Master. According to what I know and according to what I think, the approach to this question, for a point to lie on the plane, I think Z must be 0.
For a point to lie on a plane, you think Z must be
Z
0.
must be 0. Yes.
Why Z? Why do you think it should be Z 0?
Then I get off the track.
Okay, thank you very much for that very good idea. Z must be 0. I want you to think about what Z is 0, what Z is 0 means. Under the normal, here we are looking at 3 dimensions where we are having X, we are having Y, and we are having Z. If we talk about Z being 0, I see that we are talking about having an XY plane. Not necessarily we are having an XY plane. We're having a plane in 2 dimensions, the XY plane. So think about it. Let us also hear from Andrew. Andrew, what do you think?
I think for that, to show that that point lies on the plane, that means it should satisfy the condition of that plane. Like in that case, we are having 4x plus 3y minus 3z minus 4 is equal to 0. And for a plane, we know we always have like the normal times the position vector should be equal to the normal times also like, let me say N OA, assuming that the point is OA, the position vector is OA, should be equal to N R. So in that case, when I have 4, then where there is X, I put 1 plus 3, where there is Y, I put 1 minus 3, then where there is Z, I also put 1 minus 4, it should give me 0.
Thank you very much for that bright idea, Mr. Pio. Can I have Bach also? Bach, what are you saying?
My idea was the same. For a point to lie on a plane, it must satisfy the plane equation.
Thank you.
So
for
the
point to lie on the plane, it must satisfy the plane equation. The same happens if it is a line. For a point to lie on a line, for a line to go through a point, it should satisfy the equation of that line or the equation. The coordinates should satisfy the equation. So what we do is simply substitute the X is 1, Y is 1, Z is 1 in our equation and see what we get. What I want to emphasize here is that let us not start by assuming that it is 0. What do I mean here? Do not put 4x plus 3y minus 3z minus 4 equals to 0. That will be now an assumption. Just work on the left-hand side, substitute the coordinate, and see what the left-hand side gives. And if it gives what we have on the right-hand side, then you can conclude that indeed it satisfies. So what do I have on my left-hand side? So that's what I would expect you to begin with. What do we have on our left-hand side? On our left-hand side, we have 4x plus 3y minus 3z minus 4, which is what you have already mentioned. I'm only putting it in writing for some of us so that we can all follow. So substitute our point A Sorry for that. I am disturbed by this noise here. May I request someone to be in charge of that noise? Chris Peters, I'm going to make you a co-host so that you keep checking on them and tapping on and closing their mics. Chris Peters, you are given that right. If there's someone else who feels he can do that and help us, but Chris Peters, that is a duty. Please keep following them, tapping on their names and muting them.
All right, sir. Thank you.
Thank you. So that we move. Victoria, you have something to say? Yes, Victoria?
It was by mistake, sorry.
Okay, we can go ahead. Okay, thank you very much. Chris Peters, please help us. Let's move and see. If you have a challenge, you let us know. Okay, thank you. We are saying the coordinates of A are 1, 1, 1, meaning our X is 1, our Y is 1, and our Z is 1. So what do we have on the left-hand side of our equation for this plane? We have 4x, substitute a 1 there. Then we have 3y, substitute a 1 there. We have a 3 minus 3z, substitute our z is also 1, and subtract 4. I'm sure each one of us has already worked this out. 4 times 1 is 4. 3 times 1 is 3. 3 times 1 is also 3, but negative. And we have a minus 4 in our work. And when you work out a 4 plus 3 minus 3, you can see that this gives us a 0, which 0 is what we have on our right-hand side. So this gives us 0, which is our right-hand side of our equation. And since it satisfies, so this tells us that the coordinates of the point satisfy the equation of the plane, meaning that the point therefore lies in the plane. The coordinates of the point satisfy. So the coordinates of point A satisfy our equation for the plane. The equation of the plane meaning that, which implies therefore that the point lies in the plane. I don't remember what exactly the question was saying. Show that the point does what? Lies in the plane, yeah, which implies that the point lies in the plane. Thank you very much. Then you can draw that conclusion, implying that the point A lies in the plane. The point A lies in the plane. Thank you. That should give us our first 2 marks. I am mentioning once again, do not start by assuming. What do I take to be the assumption? Do not work out left-hand side is equal to left-hand side. Okay, the equation, do not write that 4x plus 3y minus 3z minus 4 is already 0. You substitute, and again, you come up with 0 equals to 0. By the way, because you already have the right-hand side, you end up with 0 equals to 0, which is a trivial statement. 0 equals to 0 is everyone knows. That's not what we want to see. Here, we are beginning by saying we do not know what the coordinates of A will give us. Let us find out what they will give us. Then when you substitute and it gives you the 0, that is when you can now draw the conclusion that indeed it is 0 and the left-hand side and right-hand side are equal. I can see S's are there drawing those conclusions very well in the chat. Thank you. Part B, if there are no questions, if there's any question, please feel free. Part B, can we share what we expect to happen for part B?
Excuse me, sir.
Yes,
Excuse
please.
me, sir.
Yes, please.
Sir, now, when is my idea applied?
The idea of Z equals to 0?
Yes, sir.
Was that the idea that you shared with us, Peters?
Yes.
I said that when Z is 0, it means that we are not having the Z, how would I call it, Z coordinate, and the point,
Yes.
whatever it is in a two-dimensional plane. I don't know exactly what you would want to hear, but as we look at some questions, we may find where it is necessary to use that. But if you are testing a point on a line and a point in a plane, those two are the same. A point in the plane and a point in the line, what you do is you substitute the coordinates in the equation of the plane, in the equation of the line, and they should satisfy. And satisfying means you get your left-hand side equal to the right-hand side. That is all. Thank you. Then we are having part B, which is talking about, who is there to read for us part B?
In most cases, the approach value is always
find the perpendicular distance from the plane to the point B151.
Thank you, Cesar. Find the perpendicular distance from the plane to the point B151. Keep it somewhere, please. I'm going to scroll so that I get where we are writing. Find the perpendicular distance from the plane. This plane of ours, the 4x plus 3y minus 4z minus 3z minus 4 is 0. So to the point B, from the point B151 to that. Okay, anyone ready to share with us what you think we should do? So here we are having a point somewhere, that is our point B, which is 151. And we're having a plane somewhere. We are having a plane somewhere. And we are looking at the perpendicular distance. It could be something like that. Sorry about that. Please forgive my drawing, but I'm looking at, it should be a distance that is perpendicular. And what is that perpendicular distance? This is our plane, 4x plus 3y minus 3z plus minus 4, 0. Okay, any idea? Can you share with us so that we agree? Yes, any idea that you're ready to share with us? Someone ready? What should we do in this case? Yes, Andrew.
Okay, to try on that, to get the distance, we should get the magnitude of the formula is ax1 plus by1 plus cz1 plus d divide by the square root of a squared plus b squared plus c squared. So we get the magnitude. So in that case,
go ahead. For
in that
plane, case, so the plane, Andrew, you are using is the plane x plus by plus cz plus d
plus d
equals to 0. From which point? Yes. The point, and from which point? What should we take to be our
point? From point 1, we have from point B, that is 1, 5, 1.
No, generally, if we take the general one,
okay,
from the point, okay. Let me call it also
x1,
okay, I can use P.
x1, y1.
Yeah, I can use P from point P, which is x1, y1, and z1. So what is the perpendicular distance? The perpendicular distance will be A,
for
x1, that you substitute x1, then you substitute y1, then you substitute the coordinate of z1, and you have the d. Then you take the magnitude of that, and you divide all by the square root of
a squared plus b squared plus c squared
plus b squared plus c squared. Thank you very much. That's our formula for finding the magnitudes, for finding the distance. This magnitude can be all, but even if it is just up, we take the absolute value. That is the important thing. So that is the formula for finding the distance of a point from a plane, perpendicular distance of a point from the plane. So I want you to use it in our case and get me the answer. I'm giving you a few minutes. Use it in our case. Look at the equation that we have for the plane. Look at the point, coordinates of the point, substitute, get the magnitude, and give me the answer. 2 minutes. 2 minutes, I'm giving you 2 minutes. I think it is even too much. Please substitute and give me the answer. Okay, are we ready? I can see some answers in the chat. Victoria, 2.058. Anna, 2.058. Thank you. I see Amon Angela. Teacher, can we use the formula? Amon Angela, which formula are you talking about? I don't know yet. Opio is there, I think. Opio is there. Lena. Anna. Okay, good. Gertrude, is that Gertrude? Hamza. A square root of that one, 12 over the square. Good, Eric. Thank you. I can see people who are trying out, and I think that is very good. Thank you very much. We can just check for those who are David Kamia. I like that. My second question is also appearing. I don't have space where to write as such, that tells me, but no problem. You can write here. Can we go ahead and write here? Is someone, I don't know whether you can annotate. You would have written for us also. Can you annotate here? Is there someone who has tested if they can annotate here? Please find out. So that each one of us gets a chance to try out. Okay. Let's use this very space here. For those, if there is anyone who is not yet there, what have our friends done? They have substituted in our D, sorry about that. Our D is get the equation in that form. Now, what is special about the form in which the equation is written? You make sure you have equals to 0 on the other side. That's the only thing that is special. Make sure in your equation, you have equals to 0 on the other side. So you are going to substitute for x, our x for b from here is 1. So substitute that 1 for x. Plus 3y, our y here is the 5. Substitute that 5 from the coordinates of the point, minus 3z, our z here is 1 from the coordinates of the point B, minus 4. And all is over. Then take the coordinates. 4 squared, 3 squared. We are taking the 4 and the 3 and the negative 3. Those are the coefficients in our formula. So add the negative 3 squared. All of it is under the root. So you get all that under the root, and afterwards you get the magnitude for all that. So for those who have tried, you will see a beautiful 4 plus 15, take away 3, take away 4. And all this is over the square root of course, it is 16, and it is positive 9 and positive 9. All of us know that when we square that negative, we get a positive. So take the absolute value of that. Allow me to write here. I expect you to write going downwards. It is the order, it would be the better thing. I think let me not go there, since that's not what I want. So here, this is 19 when we add those two. And when we subtract the 7, that is 12. And is all over the root of 34 when you work out. And our calculators are good. They can give us a value, but even if I left it at that point, I'd get my marks. But please go ahead, 12 divided by the root of 34. So it is 2.0579, which people have given us as 2.058 to 3 places of decimal. So this is 2.058 units if you're giving to 3 places. That you can give as many as possible. I saw someone who gave more. Though I think it is 5800 to around 5 places of decimal. Okay, those are our 3 marks to give us the 5 marks. Are we comfortable there? Is there any question? Yes, Mr. Mainja.
Good morning, sir. So
yes,
I was asking, what's the use of the magnitude signs if we are taking the negative values of the A, B, and C of the A, B, and C values? What's the use of the magnitude then?
Come again.
Like we are putting magnitude like to show absolute, in that we are not taking the negative or positive value, just getting a value from it. Now, why are we taking the negative values of A, B, and C?
Of C? No, the magnitude is coming in here. If I had, you can have this 4 plus 15 as we have it. And somewhere, somehow, this side, you may have a negative 20, negative 5, something like that. And you come up, it is very possible for you to come up with negative 7 here, or negative whatever it is, okay?
Yes.
So if I took this, subtracted 25, does that give me negative 6? So you can get a negative 6 over the root of that. Take the positive value of that, because we are talking about distance, and it should be an absolute value.
Okay, sir. Thank you, sir.
Okay. Okay, if there are no other questions, I think we are good to go to the next. What is in the chat? In the chat, we still have more answers, and that is good. Now, I want to talk about the answer from Andy. Andy, your answer is wrong. What is it? Andy, if I am getting 2.05798 and so on, then I should round off if I've chosen to give 2 places of decimal. If you give 2.05, that is wrong. Please do not round off if you have chosen 2 places of decimal, so that you can say 2.06. But whenever you have a chance to give as many places as possible, please give more. There's nothing wrong with giving more. Okay? I hope that is okay. And it's not a point, it is the distance of the point from the plane. Chris?
I'm now okay. So
good morning, sir.
Good morning. Chris, you are now okay?
So we're told that for paper 2, the standard number of decimal places is 4 decimal places.
There is a certain number of decimal places.
We're told that for paper 2, the standard number of decimal places should be 4 decimal places.
I may not talk with the authority.
Yeah, we're told that in paper 2, we should use
because it depends on what you are finding. Even here, if I was to find logarithms in paper 1, I cannot give less than 4 places because our mathematical tables are 4-figure. So in many of those paper 2 questions, the tables are 4-figure. So you should be giving those 4 figures in most of those cases where you're using the tables, because you're using tables. But you can go ahead and ask more about that. Hear what I'm saying. It is good to give as many. Okay, thank you. That is our second question. And this time it is a section B question of 12 marks, longer than the other one. And I think now we are picking speed. Maybe now we are going to move a little faster, because if we are to discuss slightly more, we should move slightly faster. Thank you. Can I have someone to take us to tell us what you are expected to do? Maybe first read for me the question. Someone to read for us. Can we get a reader very fast?
Four points A. 4 points have coordinates A, that is 3, 4, 7. B, 13, 9, 2. 1, 2, 3. Then D, 10, K, and 6. The lines A, B, and C D intersected.
Okay, thank you. The lines intersect at P determine the vector equations of lines A, B, and C, D. That's the first one, 6 marks. Vector equations of the line A, B, and C, D. Can I have your input here? How are we going to get the vector equations of these lines? Can I have your input, please? Vector equations of the lines A, B, and C, D. Yes, can I have your inputs, please? What is the, and how do we get the vector equation of a line? I can see Amon saying we can first get AB. Good. What is AB, Amon? What is AB? Yes, we get AB. What is AB?
B minus A.
That is true, but what is it standing for? What is it giving us?
Direction.
The direction of our line. So what does it mean? For us to write the equation of a line, what do we need? If I have a line, what do I need to write the equation of a line? So if this is my x-axis and this is my y-axis, and I have, or this is a 3-dimension. Anyway, but let me just see for general. If this is my line, and I have a point on that line, point A. I'm sorry for that. So I'm looking at, suppose I have a point A here, and I have a general point on my line. Suppose I have a point A, sorry. So I have A, and position vector. Then I have a general point somewhere with position vector R. The vector here is the vector parallel to the line. So if this was general point R. So how do I get the equation of the line? From our knowledge of vectors, OR, vector OR which is from here to there, can be obtained by taking OA and then AR. So it is OA and then AR. OA has coordinates that we are very much aware of.
Excuse me, sir.
Before you come, Mr. Suga. Is that Mr. Suga?
Not really.
This is Alexis. Just a minute.
Yes. Okay.
OA has coordinates A that we know, and AR is parallel to the vector B, which vector B is the vector parallel to the line. So meaning that if AR and the B are parallel, if AR is parallel to the vector B, then AR is equal to some scalar, which in this case we use lambda, we commonly use lambda in most of the books, times B. This is the vector equation of the line. This here is the vector equation of the line. So A is position vector of 1 point on the line, B is the vector parallel to the line. So in this case, the vector parallel to the line is the vector that Amon told us is AB. Okay, let me hear from Alexis, then in Suga. Suga, are you still interested in talking to us? Alexis.
Okay, so I was asking about that OR. Like, what was the general what? Why were you finding OR? Was it the position vector for R for A, or I didn't understand that step?
The OR is the position vector of the general point on the line. So our R is the general point on the line, or what we call the arbitrary point. And it can stand for any point on that line. That is what makes an equation, because it should be able to define any point on the line. So that means R is a general point or an arbitrary point, and it can be anywhere on our line. Yes, please.
That means we are finding that we are trying to find the general equation of a line.
Exactly.
Okay, thank you, sir.
You're welcome. Yes, Jerome?
Good morning, sir.
Good morning, Jerome.
Yes, teacher, I was just giving a suggestion.
Yes, please.
Because I've calculated the vector AB.
Yes.
And I got 10, 5, 5.
Good.
And okay, and the directional vector, it must be parallel.
Yes.
Yes. And when I get 10, 5, 5, I thought maybe to get the directional vector, am I supposed to factorize out the 5 and remain with the 2, 1, 1, and I assume that the 5 is the lambda. Then I also include the point A, because according to the equation of the line, we are having the vector, which is x, y, z, or the r, equaling to A, which is any point on a line, then lambda, the directional vector.
Okay, thank you, Mr. Suga. I think you have a big point there. And there's nothing, what would I say? We can share a little about it. Can we go ahead? Nsuga is already ahead. Can we go ahead and find our equation? Please give me the equation if you have gone ahead to write it. So our first part, which is part A, vector equation of AB will be R equals to A, the position vector of 1 point on the line. What point have you chosen? Here we are free to choose either A or B because we have both of them. I am sure many of you have chosen A. I can write B just to show you that even B works. Anyway, give me your preference. What point do we take?
Let's take A.
Let's take A. So we take A. position vector is 3, 4, 7. Now a column vector, or you can use I, J, and K. That's scalar. Now in this case, we can use the common scalar lambda and AB. Like we are, AB is obtained from OB minus OA. So please go ahead and subtract it, and that will give us some OB, which is 1392, minus OA, which is 347. So when you subtract it, Mr. Nsugga is already ahead of us here and is telling us that, so allow me to write here, R equals to 347. R equals to 347 plus the lambda. And when we subtract, Mr. Nsugga tells us we get 10, 5, and negative 5. We can give our equation like this. There's nothing wrong. But I would also not give that. I'm like Nsugga. 10, 5, negative 5 has a common 5 that I see. So I would factorize out that 5. Mr. Nsugga, if we factorize out the 5, where do we go? If we factorize out the 5, we are going to write our equation as R equal to 347 plus 5 lambda. Then we have 2, 1, negative 1. Now the point you are bringing here is that this 5 lambda is still a scalar, and we are very free to write it as something else. So I can write my 347, and 5 lambda is still a scalar. So I can write it as my mu, and I have 2, 1, negative 1. That is very fine. Very okay. Yes, please. Any comments that we have? Can I hear from you? Hoping we have answered Mr. Nsugga.
Excuse me, sir.
Please go ahead.
If you had left it to the other point without introducing them, you wouldn't you get any mark?
No, what did I say?
Like if you had...
Who is this that I'm talking to? This is Alexis.
Yes,
Alexis,
sir.
what I said was that it is very okay. So you are not getting any mark. You are getting all the marks.
Thank you.
Huh?
Thank you, sir.
You are getting all the marks. I only said that there's a common 5, and I'm one of those people who loves noticing that kind of thing. When you factorize that 5, you notice that that vector 10, 5, negative 5 is parallel to the vector 2, 1, negative 1. This looks nice to give, but you will get the marks at the other point. Amon, Angela.
Yes, teacher. I have a question.
Go ahead.
Why did you decide to make the 5 lambda mu? Why didn't you use it the way it is?
Okay, I'm following the format of an equation of a line. R is A plus lambda B. From that format, the A is the position vector of 1 point on the line, and that position vector can be either the A in our case or the B. Any can go. And then we have lambda as a scalar, any scalar. So that's why I'm saying here we have our 5 lambda still scalar, which we can represent as scalar mu. There's no point in factorizing out that 5 and leave it there. It doesn't really, but if you can give it like that, there's nothing wrong still, because you have, if you write it that way, you are almost writing it the way Alexis told us to leave it there. There's nothing wrong. It looks better.
Thank you, teacher.
If you took it as another scalar.
Teacher, next
yes, any other addition? Someone?
Jerome.
Someone is still telling me scroll up. Jerome, what is Jerome saying?
Yeah, so even if you don't write the Cartesian equation and you leave it like that, you get all the marks.
Can you read the question, Jerome? What does it want?
Do I get the?
Can you read the question?
When they talk of the, teacher, I'm asking, when they talk of the vector equation.
Is the vector equation the same as the Cartesian equation?
Yeah, so is one penalized if he writes the Cartesian equation? In this case, when they have told them to write the vector equation?
Tell me your stand. You are now the one with the, if you were the judge, you are the one in the chair, you are the teacher, and you ask for the vector equation, and I give you the Cartesian equation, what would you do?
Teacher, literally, I thought there is no difference.
Mr. Jerome, you are in charge. I want you to tell me what you would do. Take the chair and tell me, what would you do?
I give the student their own marks.
I like that. Mr. Jerome, if you ask for the vector equation and someone gives the Cartesian, has that person given you what you have asked for? This discussion is in class. Can I hear from other people? I have asked for I've asked for the vector equation. The person has given the Cartesian equation. Has the person given what you have asked for?
No, sir.
No. Yes. Time you find
that would be off topic.
Amon, I want to hear Amon. Amon seems to be saying something that is different from the rest. Marvin,
teacher was saying, I was saying that by the time the person the Cartesian equation, the person is done finding the vector equation, meaning the marks will stop at the vector equation.
If that person takes that route, no problem. If that person has the vector equation somewhere, we shall give that vector equation that that person has given. No problem. If that person gives the Cartesian equation and there is no vector equation that we want, that person is not answering the question. So if we go to what we have asked, it was Mr. So. If we ask for the vector equation and you give the Cartesian, you are not answering the question. Please give the vector which has been asked. I hope we are making ourselves clear. So this particular question is looking for vector equation. Please give vector equation. Thank you very much. Can we now write the vector equation of CD? I think now we don't have to discuss that. Please write it, give it to me. I am ready to write it down. Vector equation of CD, please. Vector equation of CD, please. Senyondo, I got the message. They have to be penalized. Those people, because that person has not given the vector. Eric, it is wrong. So to give the vector, the Cartesian instead of the vector is not right. Okay, give me the vector equation of line CD. I don't know whether you had copied the coordinates.
Teacher, take us back to the equation.
Line CD, vector equation.
The line CD is 1, 2, 3 plus.
Okay, let me write. I was still waiting for people to get the idea there, to copy the idea. Let me write.
The column vector of C.
Equation of vector equation of CD. What is the vector equation of CD? It is R. Did you write R?
Yes.
Equals to, because this is an equation. If you don't write the one side, you are not writing an equation. An equation is an equation if you have two sides equal or something like that. There should be sides connected by an equality sign. So if you simply write equal, if you simply write 1, 2, 3, PT, that's not an equation. R equals 2. Okay, R equals to what?
The column vector of C, which is 1, 2, 3.
1, 2, 3.
Plus
a scalar.
Yes, a scalar.
Allow me to use
the mu.
I used the mu in the other one. So allow me to use something else. So you can use alpha, beta, and so on.
Yes.
Then the column vector here is
10 minus 1, which is a 9.
10 minus 1, which is 9.
Then K minus 2.
K minus 2.
And the 6 minus 3, which is a 3.
So this. Peters, are you there? Please organize class, Peters, please. Thank you.
Master, I'm here. I'm working on it.
Thank you. Okay, I think this in the chat we have worked on that in the chat. Victoria, thank you. I can see you have issues there. I think I would also be like you, but we are there. Don't worry. Okay. Very much. Equation. I don't even remember who gave us the equation. Can I see the person who gave us the equation once again? Who is that? Don, what have you written there? Who gave us the equation? Okay, thank you very much, whoever gave us the equation. Now look at part B. Find the value of K. Do you have answers so that we just go? Answers for the value of K?
Yes, for me, I think because they said that the lines AB and CD intersect at point
Beautiful.
P.
They said they intersect
at point P. So if those lines do intersect, that means that their X, Y, and Z coordinates are also going to be equal. So we are going to find we are going to equate their points, and we form simultaneous equations whereby we are going to first find those constants, the scalars, then we substitute in for the value of K.
Who is that one? Is that Alan or Senyondo?
Senyondo.
Senyondo, thank you very much. I can see Alan is not muted, and every time you're talking, he's moving with you. Thank you. So can you tell me, so what should I write? Mr. Senyondo?
So it is, I said 9 plus 9 plus, for me, my line AB, I have 9 plus, I mean 1 plus 9 mu.
Where are you getting for line AB? Where is the one coming from?
Line AB. Yeah, that is line A, that is line CD. That is line CD I'm on, which is 1 plus 9 alpha.
1 plus 9 alpha.
Then 2 plus alpha K.
Then it's
minus
2 plus
alpha.
K minus 2 alpha. Okay.
Yes. Then 3K.
And
3
then
alpha.
3
alpha.
Plus 3 alpha.
Yes. Then
this
bracket is equal to.
We are going to equate this to the A.
To
the line AB, which is 3.
3 plus
2 mu.
Plus 2 mu plus 4. Yes. Then 7 minus mu.
Good. So line AB and line CD are equal at the point of intersection.
Yes.
We equate the equations, and that should be giving us the point of intersection. And when we equate the equations, we are going to equate for vectors. The X coordinates will be equal, the Y coordinates will be equal, and the Z coordinates will be equal. The X coordinates are what? 1 plus alpha, 1 plus 9 alpha. You forgive me the way I am using my board. I am just looking for space because I see it is done. 1 plus 9 alpha is 3 plus 2 mu. Sorry, this should be 2. Oh, this should be 2. 1 plus 9 alpha is 3 plus 2 mu. Continue, so we are having a 2 here. And so this can be written better as whichever way you want. 9 alpha minus 2 mu, if I take this to the other side, equals to 3 minus 1 when I bring the 1 to this side, and that is equal to 2. Then you can also write the rest and write them properly. You will formulate those simple equations. So the K minus 2 alpha, the K minus 2 alpha, when the mu crosses to this side, it will be minus mu. And when the 2 crosses to the other side, this will still be equal to 2. And finally, the 3 alpha plus mu. When this mu crosses to this side, it will be a plus. And this is equal to 7 minus 3, which is 4. These are the simultaneous equations. There are 3 of them, but with the 2 unknowns. This is 1, 2, and 3. So 1 and 3, equations 1 and 3 are enough to give us the values of alpha and the mu. Please solve and give me the values. Equations 1 and 3 are enough to give us the values of alpha and the mu. Please solve and give me the values.
Hello.
Yes, please. Are you ready?
I've got an 8.
8 for what? Because we are looking for 2 values, I expect you to be giving me 2 values.
Of the constants?
Yes. Oh, you are already at the value of K. Please begin with the constants.
My lambda is 2 and my mu is 2/3.
We don't have a mu, we have an alpha.
We
don't have a lambda.
I used the mu.
Okay.
I used the mu and lambda.
Can you come back and show us which one is mu in yours, because I will need to give my values. What is my alpha? And what is my mu?
My alpha is 2/3.
So it is 2/3, and my mu is 2. Beautiful. 2. And so after getting those ones, how did you use them?
I substituted in equation 2.
Beautiful. Substitute in equation 2, then you'll get 2/3 of K minus 2 minus mu, which mu is 2, and this is equal to 2. And then you solve. I'm sorry, you forgive me for the order here. I am fighting for space somehow. Is that fine? So from that, when you solve, I think I can have created the space here. I don't know why I feared. I could have created space here. Not so. No. Okay. So the K equals 2. Please get the K, everyone. 2/3 of K minus 2. 2/3 of K minus 2. Then minus 2 is equal to 2. Everyone is solving. Give me the value of K. This guy is already there. For him, he has given us the K already. I don't know whether everyone is there finally. Which value of K have you got, guys? I can't hear, I can't. Are we there? Peter? Peter, please. I just want to see. I wanted to see if I'm still in class. Okay. Can I hear from you guys? Are we there?
Yeah, still.
You are still working out?
Yes.
Harry, please get me the value of K. That answers our second question.
My case, so I don't know whether I'm correct.
Your case? Peter's, your case what?
2.
Please check and see. Mine is not 2. And someone else has already given us, I don't remember that guy. Where is that guy who got an 8?
Excuse me, teacher.
Yes, Martha.
My
Jerome,
case 8.
Your case 8.
Yeah.
Jerome, you are also getting 8.
Yes.
Beautiful. I am also getting 8. Peters, where are you? Can you get there? You don't know how to multiply by the fraction 2/3. Where is the issue? Are you using the 2/3 and the...
Master.
Yes, please.
Then I got mu as 2.
You got mu as 2?
Yes.
And alpha as?
2/3.
2/3. Please go ahead. Those are the very values that we got. Go ahead and use them. We have already even indicated the equation where we can substitute them. In the second equation, we got this.
Okay, sir.
From the second equation. And we are using them there. Please use them and see what you get.
Okay, sir.
Okay, do we go on, please, guys? Rennie, K is 8, Alan, K is 8, Nachtende, K is 8, Marvin, K is 8, Alexis, K is 8, Angela, K is 8, Senyodo, K is 8. Beautiful. Everyone is there. Beautiful.
Yes, K is 8.
K
I've
is
gotten
8.
the answer.
Queen,
Yes.
K is 8. George, K is 8. Davis, good. Guys are already there. Now, guys, can we go to the last part, please? I'm glad that we are there. Please let us answer the last part. And the last part is coordinates of P. I don't remember whether it is P. The point of intersection. The last part is coordinates of P. Remember, P is where the lines intersect. Please get me the coordinates, and that is what I'm waiting for in a short while. There are already messages here. I hope that is K is 8, Magic Ande. Chris Peters, K is 8. Victoria, K is 8. Is that Victoria? Yeah, K is 8. Aaron, K is 8. I think that is it. That is it. Can you get me the coordinates of P, please? That's where we are.
763.
Come again.
765.
Martha 765. Beautiful. Davis 765. Beautiful. 765 is that. Kulova, what did you get? I had a 3 somewhere. Kulova, what did you get? Okay. Carol wants us to explain how we get 765. Please, how do you get there? Someone to help us? How do you get 765?
Me, teacher.
Yes, please, Jerome.
As we were equating the two vectors, okay, which was the R? Okay, in the equations we got, where we had 1 plus 9 alpha, then alpha into K minus 2 plus 2, 3 plus that. Then you can substitute with the values of alpha, then into this vector, then you can get the points. Or you can substitute using the mu in that case, which was 3 plus 2 mu, 4 plus mu, then 7 minus mu. Then when you put the value of mu, you get the point of intersection.
I didn't understand the 7 and mu. They were okay, that is the Z. Okay. Carol and the rest, these are our equations for the line AB and for the line CD. And any one of them, we don't need both. Any one of them gives us the point of intersection. So just substitute the value. If you have alpha, our mu, substitute here the mu. What is the mu? The mu is 2. Was it 2? And then you will be there, 3, 4, 7 plus 2 into 2, 1, negative 1. Or you can use this one and substitute the alpha. Our alpha is 2/3. Of course, we know our K now. It is also 8. And then you will be there. Substitute and you'll be there. One of them is enough. You don't need both. Because the two intersect at the same point, meaning that at that point, both lines are reading the same thing, or both lines are at the point of intersection. So when you use mu is 2, it gives you the point. When you use alpha is 2/3, it gives you the point of intersection. And that point, if you check, if you want me to write here, this is 3, 4, 7 plus 2 into 2, 1, negative 1. And this will be 3, 4, 7 plus, when you multiply by 2, you're going to get 4, 1, negative 2. And you can finally get those values, 7, 5. No. 2 times 2 is, this is 2, sorry. Sorry, 2, 2, negative 2. And if you add those ones, you get the 7, 6, and 5 as our point of intersection, meaning those are the coordinates of P. If there's no challenge, we then move on. If there's a challenge, if there's a someone wants to say something, feel free to say what you want to say. Alexis, you wanted to say something? I can't hear you. Okay.
Excuse me, sir.
Yes, Alexis.
So if you're always told to find the point of intersection, are you always required to find the value of R from the equation?
Oh, remember the value of the R in the equation. And I think you are the one who mentioned that at a certain point. It is the general point. So the value of R gives us a number of points on the line. Those points depend on the scalar mu. When I keep changing the scalar mu, I keep getting different points. In this particular case where we are having the intersection, the mu is 2. And when I substitute the mu, it gives me that point where the two lines meet. At other mu's give me other points. When I say mu is 3, I get a point. Mu is 4, I get a point. Mu is a half, I get a point. But this particular mu was giving me, is a mu which I got after equating the two. So it is a mu for the intersection. So our R is giving us, your question was on R. Our R is giving us different points. I don't know whether I am answering you. So in this particular case where I want the point of intersection, that point is an R. That point is an R. Do you know that I have answers for the angle? But before I go there, let me listen to Angela.
Teacher, I have a question because when you solve the vector equation for AB without factorizing out 5, the value that you get for the scalar is different. Can it also be correct?
Yeah.
Because if you put it in
it will be correct, and that value is the one that you are going to use, and that value is the one that should give you 765. It won't give you another. If it gives you another point, then that value is wrong. But I expect
no, it's giving me 7.
Yeah, I expect that. So that is the correct value for that, whatever the scalar is. For lambda, if you maintain the lambda. Yeah, that's no problem. Very okay. Okay, there we are. Thank you very much. Thank you very much. And now we have another section A question. Determine the angle between the line, that one, and the plane, that one. And I want to give you good news that Eric, is that Eric? Is already at the answers. And please, can we also join? Can we also join him? How do we get the angle between a line and a plane? You can share a little bit of that. How do we get the angle between a line and a plane?
Me, teacher.
Yes, Jerome.
We get the directional vector and dot it with a normal, which will be equal to the magnitude of the normal times the magnitude of the directional vector, then sine the angle.
I like. Thank you very much. Here we are having a line. I want to put my line like this. Oh, I remained with this pen. Sorry. Here we are having a line and we are having a plane. And Jerome is saying we are having the normal, the vector normal to the plane. We are having a vector normal to the plane. We also have a vector parallel to the line. We also have a vector parallel to the line, and we dot them. And the angle we are interested in is this angle between the line and the plane. But it is the one between the normal and the line, therefore is 90 minus theta. So when we dot when we dot the direction vector of the line with the normal of the plane, the angle between them is 90 minus theta. So what is this case? In this case, what is happening is that if I take B to be the vector parallel to the line and I dot it with the normal to the plane, by definition of a dot product, this should be magnitude of B times magnitude of A times the cosine of between them, which in this case is 90 minus theta, and I'm looking for theta. That is the reason why we are saying that when you take a B and dot it with N, you should have the magnitude of B and the magnitude of N and the sine of theta, because the cosine of 90 minus theta, from our knowledge of trigonometry, is the sine of theta. So that gives you the angle. Please go ahead and work out what is the direction vector of our line in this case. I love it when someone writes it carefully. If I had x plus 4 over 8, and I have y minus 2 over 2, and I have z plus 1 over negative 4, I would equate this to lambda, and I would come up with x equals to negative 4 plus 8 lambda, y equals to 2. plus 2 lambda, and z is equal to -1 minus 4 lambda, from which you can see that this is -4 to -1 plus lambda into 8 to -4. So the vector parallel to the line is 8 to -4. Some people say you can pick it from these denominators here, but if you have to pick it from those denominators, please make sure up here you have a positive one coefficient. That's when it is 8 to -2. And I think it was Jerome who already told us this vector, if you see a common 2, this vector is parallel to another vector, 8 to -4. If you picked a common 2, this vector is parallel to the vector 4 and -2. So you can use this one. Nothing wrong. But you can also use this one for the vector B, because those two are parallel. Those two are parallel. Okay. Thank you very much. Now, may I receive your answers? Jerome is at the answer, 69. Shamo at the answer, 69.3. Remember, Eric was already there. Why you remember? Eric was already at that angle, I think. Eric, was it? Anna, 69.3. Amon, 69. Gachang, 69.33. Who else is there? Oh God, I think this is nice to see. 69.3. Amon, 69.3. Who else? Kulova, thank you. Bak, thank you. Lina, thank you. Hey, people are running. Shafiq, what are you having to say? Who is lost?
Lost.
Chris.
I'm lost.
Shafiq, eh? You are not seeing where the angle
Yes.
is. You are not seeing where the value is coming from, eh? Okay, can someone guide us? How did you get to the angle? Can someone guide us, please? How did you get to the angle? So that David is there. Please let us also see that Shafiq is with us. Guide us. Someone who is ready to guide us. How did you get there? Please guide us.
I also have a question.
That is Peter. Chris, yes.
I also have a question, sir. I have a question.
Go ahead. Go ahead and ask.
Master, where is B and where is N?
B is the vector parallel to the line. N is the vector perpendicular to the plane. And so,
And so how do you get them from the equation?
How do you get them from the equations? I want someone to guide us. There was a hand up. Do I still have it? Back. Back, we are all ears. We want to hear what you are.
We already got our equation. D dot N is equal to magnitude of D times the magnitude of N sine theta, right?
Yes.
So we get our direction vector from the line equation, which we got as 8, 2, and -4.
Before, back a little, just a little back. Those who were asking, do you remember that we have shared the direction vector, 8 to -4? We obtained it here together. 8 to -4, and we have said you can use 8 to -4, or you can even use this one because the two are parallel when you take note of that. We have gotten it here, the direction vector. I hope I hope you were following. Okay, back, continue, please. I'm sorry.
So we also get our normal vector of the plane using the plane equation, and we can get it as 4, 3, and -3.
Where are you getting
from the vector,
4, 3
from the plane equation?
Where are you getting 4, 3, -3 from?
From the plane equation.
How do you get it from there?
From the equation of the plane.
How do you get it from there?
Okay. Our general equation of a plane.
Someone is saying here that n is the coefficient of x, y, and z in the Cartesian equation of the plane. The coefficients are the ones that we are taking in the Cartesian equation. So we are taking the coefficient of x, the coefficient of y, and the coefficient of z. I don't know whether they are, they can be seen. Please look at those coefficients. The coefficient of x, the coefficient of y, and the coefficient of z. Thank you very much. Back, you are on the floor.
Yes, so using the coefficients of x, y, and z, we got our normal vector. Then we go back to our equation, which is b dot n is equal to magnitude of b times magnitude of n sine theta. When we substitute for the direction of the plane and the normal vector in the equation, this equation that is shown on the screen, we can be able to find our angle.
Please go ahead. What is our b?
Our b is 8, 2, -4.
Dot n.
The normal vector, which is 4, 3, -3.
This is the magnitude. How do we get the magnitude?
The square root of the squares of
Square root of those squares. Also for the normal, square root of the 4 square, the 3 square, and the -3 square. Sine theta. And our sine theta is what? And no, it's just sine theta. So we go with sine theta. Shafiq, you want to say something before we continue?
So teacher, when do we use sine theta or cos theta? Because my equation, I had used the direction vector dot n is equal to the magnitude of d, magnitude of n, cos theta.
Oh, so, yes.
I
explained where
the
sign.
I move around like 30 minutes.
Please.
Sorry, we still have an issue of Seguja. Shafiq, I explained where the sign came from. I said that if you are having a line and a plane, the angle we want is this angle here. This is our theta. The angle between the line and the plane. However, what we know is the normal, and the normal is this way. So I said that the angle between the line and the normal will therefore be 90 minus theta. So I use the cosine of that angle. And when I use the cosine of that angle, I said, from our knowledge of trigonometry, the cosine of 90 minus theta is the sine of theta. That's how sine theta came in our work. Because we are dotting B and N, and the angle between B and N is not the angle that we want. The alternative that you can do is you dot B and N like you have done, and you get that angle. After getting that angle, please do not give that as your answer. Give this other angle because this is the one that we want. So take a 90 and subtract that one that you have gotten there. If you are using cosine theta, Shafiq, take the 90 and subtract the angle that you got, then you will get the angle between the line and the what? And the plane. Have I answered you?
Yeah, that's why I got a long answer.
Have I answered you now?
Yes.
Okay, thank you very much. Okay, go ahead. Can we get our angles then? Can we get our value? That then we can get, we can dot and get there. And when we dot and get there, please go ahead. I don't know whether everybody is now. Who was it? Back, you were leading us. When we dot here, what do we get? Back, can you lead us again? When we dot, what we get?
You can say.
Yes, please.
50.
How do you get
50.
there? You are multiplying the 8 and the 4.
8 times 4 plus
32.
2 times 3.
Very good. Plus 2 times 3, which is 6. Plus 12.
Plus negative 4 times negative 3, which is 12.
Beautiful. And down here, we are having the square root of?
Root 84.
84. Then the square root of?
Times root 34.
34 sine theta. I want to think that everyone can get there finally. Chris Peters, you had a question on this. Are you comfortable? Yours was to see how do we get n and how do we get the direction vector of the line and the normal to the line.
Now,
okay?
Yes.
Yes, okay? Very good. So each one of us can get the angle. And when you get this angle, I've not tried it personally. I want to believe that what you gave is what we are getting. 50 divided by those root of 84, also the root. Anyway, I want to think that that is what we are getting. Please, that is 69.3. 1 decimal place is enough for the angle. If you give 2, no problem. And no problem if you give more. Good. Good. Any other comments? Can we go to the next? If there's nothing that you're saying, can we go to the next?
Excuse me, sir.
Yes, please.
Oh, you rounded off with the angle to 1 decimal place.
I can round off to 1 decimal place.
You can, or is a must. It's a must.
It's not a must.
Because
I said 1 decimal place, if it has not been asked for, is enough. But if you give more than 1, nobody is going to punish you for that. You are actually better.
Okay, thank you.
But if they ask you for 1 place, then please make sure you give. If it is asked for, just give what has been asked. If it is not asked for, 1 decimal place is 1 decimal place is enough. Someone wants to know when we are finishing. I think we are free to set our finishing time. In my mind, I said that we shall finish at 1, but you are free to suggest. Can I have suggestions on this? Someone wants to see how they plan their data. I don't know whether it is data.
Excuse me, sir.
Yeah, yes. Are you talking about the time to finish?
Yeah, I'm talking about the time I'm complimenting about something else.
Okay, please go ahead.
So, are we going to always only cover vectors in the time you've estimated?
Or yeah, what did we say? We said that our discussion is on vector. That was something that had been asked. But we agreed that if you feel that you want us to talk about something else, please go ahead and mention it. But this particular one had asked, the request was, can we revise vectors? And we came in to revise vectors. But if you want something, if you want to make a comment on something else, please go ahead and we can always talk about it.
No, like actually we should stick to vectors as it was asked.
That was a request, and we came in for a discussion on vectors. So for me, the questions I picked were some questions on vectors. Okay. I want to think that we can go. Martha, make your comment.
So I was just asking her about the math too, because we have
not in this discussion.
Okay.
Not in this discussion. Okay, that is.
Thank you.
You can write in our chats, in our WhatsApp groups, and if you want something, we can always organize. But not in this discussion. This discussion is for Math 1, and this particular one was on vector, except if you want something small that we can talk about. But personally, what I prepared is vector because it was the demand that can we revise it. Okay. Can you work out this particular question? And then I can give, there's a mock question somewhere, and then we can agree if there's something different. The position vectors, can I have someone read for us?
The position vector. The position vector of vertices of a triangle
Shafiq, you get lost. Is it network? Is it my network?
No. Okay. The position vector of the vertices of a triangle are O, R, and S, where O is the origin. Show that the area A is given by 4 A squared is equal to magnitude of R squared times magnitude of S squared minus into brackets R minus S over it's R dot S squared.
Okay. So we are given position vectors of the vertices of a triangle. I want to think about a triangle and call it ORS. I want to think of the triangle and call it ORS. So I want to take this as my O, R, S. Position vectors are R and S. And usually say this angle can be angle theta. So if A is the area of the triangle, under the normal, how do we get the area of the triangle? If I had those sides Oh, this is vector S, sorry. This is vector S, it should be a small s. Mine doesn't look so small. There should be a small s there. And it is vector. There's something that I've not mentioned seriously here. Please, when you're handling vectors, can you make sure that you respect the symbols, vector symbols, please. Respect the vector symbols. It is in our interest that we see you represent vectors and represent vectors properly. Okay, there is a request in the chat and I'm going to forward it to Mr. Kaziwa about our schools, our discussion to continue even when schools open. Usually when schools open, there is a little of this because many children are at school. But for those who are at home, you can always express this need, but I'm going also to forward it to the administration for help. Okay, please. Do I have have I got any, what did I say? Have I got any contributions? Do you have any ideas of, can we share ideas of how we should go about this? Can we share ideas of how we should go about this? Show that the area, this is a UNEP question, 20 what? I am not so sure. But this is, yeah? 2018. Yeah. Please go ahead and can we share this? What should we do?
Excuse me, sir.
Amina? Alexis, let me hear from Amina first.
Okay, normally if we are to get the area of a triangle in vector format, it would have been a half magnitude of S, the magnitude of the vector S, that of vector R, the sine of the angle between. That's why we're going to build our foundation from that principle.
Thank you very much. I love all the words that you are using. Our foundation, that principle, etc. It is also nice. Area of this triangle. So when we say our area is A, it is going to be a half times the magnitude of R, which should be our base, times our height. Our height is the magnitude of S, the sine of theta. If you were to take a note here, this is what we are talking about. This should be our height, and this should be our base. So our half base times height, and the base is going to be the magnitude of R, and then the height is magnitude of S times the sine of theta. Beautiful. That is our foundation, and we are going to build it from that. Oh, those are very beautiful words to hear. Okay, then can we look at what we want to produce, that expression, and see how we can connect. That is what we want. So anyone with a suggestion, how do we connect what we want with what we have? Amina told us this is our foundation. That is our foundation. How do we use our foundation? Good, Alexis.
Excuse me, sir.
Go ahead, Alexis. Alexis, is it network? Not getting you.
About the naming of the triangle.
I hope, am I clear, guys? My network is my network. Can you hear me? Am I clear? Can you hear me? Is my network okay?
You're clear. You're clear, sir.
Okay, thank you very much. So that means that Alexis, your network is the one which has an issue.
About the naming of the triangle.
The naming. Did you say naming?
Naming.
Alexis, can you type in the chat? But I'm going to talk about the naming. I don't know what is not in the naming, but can you type in the chat, please? There's an issue of network right now with your network. I don't know where the challenge is coming from. But naming, what did I look at? I just read the question. What is the question talking about? It is talking about a triangle with vertices that have position vectors 0. The 0 position vector is the one at the origin. R, I'm the one who chose that the one with R, let it be the capital R point with position vector R. And the one with the vector S, position vector S, let it be the capital S point. You are free to call them any other, should I say names? You are free to label them with other letters, but you are not free to change vector R, position vector R, that one is given in the question. You are not free to change position vector S, that one is given in the question. But you can label them with different letters if that is what you want. But if you label with different letters, the vectors still remain R, position vectors remain R and S. What else did I want to say about this? Let me first see what we have in the chat. Yes, his network. Okay, his network. In the chat, we are talking about Alexis' network. I don't know what has happened to it because we have been hearing from him. Mr. Senyondo, you have something to say. Senyondo?
I want to bring in a contribution about that previous equation that we have written. Where we said A is equal to a half. Yes.
Where we said?
Where we said that area is equal to a half the magnitude of the position vector of R and S, then times the sine theta. Previously, we said that the magnitude of R and S sine theta is equivalent to the cross product of R and S. So I would like, instead I would replace that magnitude of R and S times sine theta as the cross product of R and S.
Okay,
so
thank you.
I wanted to contribute.
Thank you very much. But Senyondo, I want you to think about, you are telling us to go to the cross product. The question is telling us to use the dot product because we want to produce the expression that the question has given us. When we use the cross product, shall we get there? I want to say I'm not very comfortable because I don't know whether we shall get there when we go cross products. I want you to go to the dot product because it's the one that we have. in our work. I also want to add that it is not very true that R cross S is magnitude R times magnitude S times the sine of theta. That statement is not very true. The correct statement should be that R cross S is magnitude R times magnitude S times the sine of theta times n cap, where n is the, or where n cap is the unity vector perpendicular to both vectors R and S. Recall that R cross S is a vector. Now, if you tell me that it is magnitude R times magnitude S times the sine of theta, you are actually telling me that it is a scalar. So it is magnitude of R times magnitude of S times the sine of theta times n cap, where n cap is the unity vector perpendicular to both R and S. Please take note. Take note. I don't want you to mess up the good work that you already have. If you took R, magnitude S, if you took these ones and you stopped at sine theta, this is a scalar, because this is magnitude R is a scalar, magnitude S is a scalar, sine theta is a scalar, but R cross S is not a scalar. This is a vector. So it is times n cap. Okay. Senor, I hope I'm making myself clear there. I just want put up an addition to that I thought would also be very important, most especially for your understanding. I want you to understand vector even better. Okay, if there is no other contribution, then may I say that when I look at what we want to produce, I would suggest that we go ahead and square what we have. It's my suggestion. If you allow me, I can go ahead. Should I go ahead and square, please?
Yes.
I'm looking at what we want to produce. Thank you. So square both sides. When you square both sides, you are going to get that a squared, therefore, will be equal to a half squared, which is a quarter. It is equal to the magnitude of vector R squared times the magnitude of vector S squared times sine squared theta. Now, what do I want, Mr. Senyondo? If you remember what prompted you to go where I went, you notice that we want a dot product, and you brought a cross product just because you are looking at we have it. And I think I am happy with you to notice some of those things. That is a great thing. But I am saying, now can you notice that we want a dot product and we can get there? Because if we want a dot product, it means we want to use cosine. So can you allow me to write sine in terms of cosine? It is possible. And also allow me to take the 4 straight to the other side. Multiplying through by 4, we are going to get 4a squared. And we are going to get magnitude R squared, magnitude S squared. Magnitude R squared, magnitude S squared. Then the sine squared can be written as what? From our knowledge of trigonometry.
1 minus cos squared beta.
Please come again. I want you clear.
1 minus cos squared theta.
Is that Seguja? Thank you, Seguja. 1 minus the cosine squared of theta. If we open our brackets, we are then going to say that for a squared.
Master, excuse me, sir.
Please,
Excuse me, sir.
please. Go ahead.
Please help a friend. She's not getting.
Please.
Help a friend, master.
Yes, please.
She has written to me and her question is, excuse me, sir. I'm not understanding what is being taught. Is it for senior 4 or another class? Because I'm confused. She's party floret.
Couldn't you answer that?
I could, but I'm not a teacher, sir.
No. It's saying, what is this that we are doing? What are you doing, you?
Master, I'm also trying to follow you.
Chris Peters, which class are you?
I'm in senior 6.
Beautiful.
As for me, I couldn't answer her question because I'm not a teacher. I'm not responsible for answering.
And no, you are. What we are doing is not senior 4 work, please. This is not senior 4 work. We are doing A-level work. A senior 5 can follow us, and a senior 6. Senior 4 is not senior 4 work. Please, this is not senior 4 work. Okay. Carol, is this Carol or who? I don't remember it. Carol is saying, why are we squaring? Carol, I'm looking at what we want to produce. If you look at what we want to produce, anyway, there are two. If you look at what we want to produce, things are squared. That is 1. But 2, I want to bring in the dot product. And if I'm to bring in the dot product, I should bring in cosine in our work. And if I am to bring in cosine in our work, I should square the sine because I know that trigonometry, that the sine squared can easily turn into 1 minus cos squared. So those are all things that are giving me the energy to go ahead and square. How is the magnitude sign on R and S coming? Those ones came from Amina, if you remember. And Amina is telling us that how do we get the area of a triangle? To get the area of a triangle, I can write it here. For those of us who have gone through the O-level work, you will recall, if I have the triangle ABC, the opposite side here is A, and the opposite side here is B, and the opposite side here is C. And now it is up to me. If I have this angle here as theta, then the area of this triangle is obtained as a half base times height, which is a half C. Sorry, now I'm using vector, which is a half C times B sine theta. B sine theta, I tried to remind you that that is the height. C is the base and the height is B sine theta. From our simple trigonometry, what is sine theta? Sine theta is the opposite, and this is our opposite, which is the height out of the hypotenuse, which is B, from this right-angled triangle. I don't know whether you want me to extract it out here, that this is my height, this is the angle theta, and this is the hypotenuse. So sine theta is opposite out of hypotenuse. meaning that my height becomes b sine theta. Now, what is the meaning of b? Then the b is the length of this from here to there, length SC. What's the meaning of A? Length BC or CB, and the meaning of C is the length of AB. Now, if I am in vector work, position vector here is R. The equation which I am using, this one, is not defining this as position vector. It is defining that as the length of the side. That's the reason why Amina went on to tell us we are interested in the length OR, not the vector OR, but the length OR. Even here, we are not interested in the vector OS, which is the vector S. We are interested in the length of that side. I don't know whether that helps us to pick you. Someone who is saying, why are we going on with the magnitude sign? We are taking the length, not the vectors. I hope that picks you. You will speak to us in the chat so that we get to see if you are following. So may I continue by saying, when I open this bracket, I'll multiply. When I open this bracket, I'll multiply R squared S squared by 1, and I'll subtract again the magnitude of R squared, the magnitude of S squared times the cosine squared of theta. Now you are going to ask me very many questions, and I'm ready for them. I will not fear. So what is 4s squared? 4s squared is the magnitude of R squared times the magnitude of S squared minus the whole of this is squared. So I can say magnitude R times magnitude S times the cosine of theta, but the whole of it squared. Now this brings me to the point. What is the point? The point is, what is magnitude R times magnitude S times the cosine of theta? So give me what that is. So my 4s squared is magnitude R squared times magnitude S squared minus, my question is magnitude R magnitude S cos theta. What is it?
R dot S.
Beautiful. It is the R dot S. So this is vector R dot vector S. All of it is squared. And am I free to say, and this? I don't know. I need to look at it. But I think this is what we should prove. Therefore, hence the proof. I don't know whether that is what it is, but I think so. Can I go back and look at it? And that is the proof. Is that all right? Any questions? Any questions? In the chat, someone is saying magnitude R dot S is magnitude R. Thank you, Kerry Michael. Teacher, I didn't quite get the cross product thing of R cross S. I don't know what you didn't get. Martha, what did you not get there? I remember what I said. What did I say? I said that What did I say? I said that the definition of R across S, I don't know whether that is what you're commenting about. The definition of R across S is not magnitude R times magnitude S times sine theta. That's what I said, I think. I said it is magnitude R times magnitude S times sine theta times n cap, where n cap is the unit vector of a unit vector perpendicular to both vectors R and S. And I explained it by saying that R across S is a vector. And if you take magnitude R and magnitude S and sine theta, magnitude R and magnitude S and sine theta is not a vector, because the magnitude is scalar of R, the magnitude of S is a scalar, sine theta is also a scalar. And the R across S is not a scalar. R across S is a vector. What makes it vector is the product here of this n cap. Do you know what I cross J is? What is I cross J? If you were to take magnitude I times magnitude J times the sine of theta, where theta is the angle between I and J, which all of us know as 90, you would get magnitude of I is a unit vector, so its magnitude is 1. Magnitude of J is a unit vector, so its magnitude is 1. Sine theta, which is 1. And this would give us 1. And this is not a vector. But I cross J is magnitude I, magnitude J, sine the angle between them, which is 90, times the unit vector n cap perpendicular to both I and J. And the unit vector perpendicular to both I and J is the K. So that's why I cross J is actually K. The unit vector perpendicular to both I and J. Okay, I don't know whether that answers you.
Yes,
Madam Yu. Is that where your issue was? Okay, thank you.
Yeah.
So I wanted you to pick that so that you are better. I don't want you to take the other because the other is not correct. Thank you, Bob. Bob is giving me the K. I cross J. Yeah, it's the vector K. That's where we get there. Who is this one who is telling me now the area? David Mongin, now the area. The last part. The last part is simply telling us substitute, because they are telling us that hence find the area of a triangle when the vector R is 2, 3 and the vector S is 1, 4. It's just a matter of substituting. The vector R is 2, 3, the vector S is 1, 4. Please substitute and give me the answer. If the vector R is 2, 3 and the vector S, if R is 2, 3 and S, if R is 2, 3 and S is 1, 4, what is the vector? If R is 2, 3 and S is 1, what is the vector? Please substitute and give me the vector if R is and S is that one. David is saying he's already there, 2.5 square units. Beautiful. There's a Eric, your comment, I noticed that, but it's for what? Eric there is glad. I don't know what you're glad for. Are you saying you are comfortable? I'll be very glad if you're comfortable. Please substitute. David is already there with 2.5 square units. Can I see others? Can I see others? I should also get there. I'm not there. Victoria is there. Beautiful. 2.5. Victoria is there. David is there. I want to say I'm also there.
I think maybe just a visit.
I want to say I'm also there.
So I came out was on the phone.
Noted. Kelly is there. Beautiful.
So just here the reviewer seated there. And I glanced at him, I was like, do I know you? He said, oh, no, you don't know me. I've had to speak in Luganda most of the time. I'm like, oh, hi, what? So yeah.
I can see Chris Peters, Mukisa. You, I like.
Oh, yeah, things are okay. Very.
Oh, someone is complaining about my network. You can't hear me? Someone is saying my network. Is it mine or his? George? Ah, Sandra says we can hear. George, it could be yours. Alfred is there, 2.5. Guys, I'm clapping for you. Angela is there. God. I'm glad I can see people there. Please receive hand claps from you, from me to you. Angela is there. Where are the rest? Okay, we can pick them. Some are a little slow, but please try your level best. You should be fast. And try to be as fast as you can. Finally, George, I like. Finally, George is saying, I'm there with you. Anita is there. Good guys. Good guys. Good guys. Who is this one? Harry? Oh, I'm not getting his name. Whatever how you pronounce it, is there. Where has the course disappeared? Lynn is there. The course, we used it in the definition of magnitude R, magnitude S cos theta. That is the definition of R dot S. The whole magnitude R, magnitude S cos theta is the definition of R dot S. That's how we defined that, and that is when the course disappears. Anita is there. Notuba Isaac is there. Novest is there. I thought Novest was a little making noise. I kept seeing. Wambi is saying now I'm there. Wambi, what was your question? The course. Okay. Good. Wambi is picking. Buck is there. Oh, Buck, you took long. I like you are there. Oh, Buck, you took long. Jonathan is there. Novest, I thought you were making noise. I could see here. but I'm glad you're there. I'm glad you're there. Okay, can we pick these guys? Jonathan, beautiful. Can we pick these guys? Whoever may not have reached there, please help me. What should we write? I am going to respond back. I don't remember. What was the question? I don't know whether I know the question. But there's a question which I saw in the chat. If it is in the chat, I'm going to respond. Yes, I think that was back. I'm going to respond. I'm going to respond. Okay, I'm going to respond to that. Don't worry. Can we first of all pick these guys where they are? Okay, very fast, please. We substitute. Please help me to substitute. Guide me. Who is there to guide? Who is there to guide?
Yes, sir.
Bob is there finally.
So
is also there. Okay.
In our equation,
Bob, you are ready to guide. Please go ahead and
yes,
guide us.
So in our equation whereby we have 4a squared is equal to the magnitude of r squared times s magnitude of s squared minus the dot product of rs squared. So what we do, we just get for now, work on this right hand side. And then we say for r, magnitude of r, it is root 2 squared plus 3 squared all over into brackets squared. Now the root goes with the squared and we stay with 2 squared plus 3 squared. We do the same for the magnitude of s. The root goes and we stay with 1 squared plus 4 squared. So when you work out those 2 squared plus 3 squared, you get 13. Then you multiply it with the other one of s, which is 1 squared plus 4 squared, you get 17. Now you leave that bracket alone. Then you work on the dot product. When we dot, you will get 14 squared. So then you subtract 13 times 17, that into brackets minus 14 squared. The answer you get there is 25. So 25 divided by 4, all into root, then you get an answer, which is 2.5. That's the area, square units.
I'm trying to follow what you were saying. Am I there?
Yes, sir. Yes, sir.
Am I representing you properly, or I'm saying something that you have not said? So here we can take roots at this point. We can take, you can get a square, whichever you choose, 25 out of 4. And of course, then you go and say a is the square root, isn't it?
Yes.
25 out of 4. And that square root is the 5 out of 2 square units. And because we know it is area, we don't give an opportunity to the plus or minus. We don't give an opportunity to the minus. Okay, thank you very much. I want to think that we are all there. If we are all there, then I can answer what Buck put me to task to answer. Buck, can you ask? Buck, can you ask? Is Buck there? Buck, you are not there. Okay. We could have lost Buck, but no problem. What did Buck leave in the chat? Buck said, what if I do not get this expression? And then I go ahead and use it. I think something like that. What did he say? Strictly, he said, teacher, if I didn't know the first part of the question and I instead went on to answer the second part by substituting into the provided equation, do I get marks for that part? And I would want you to answer back. Who is answering him?
Yeah, you do. You do get
Do I
marks
get
for the
marks
second
for the
part.
second part?
Yes, sir.
Who is this? Bob?
Yes,
No, you
sir.
don't.
You do get marks.
Bob says we do. Who is saying we don't?
I say we don't.
That is Chris Peters.
Yes.
Kasule. Kasule, go ahead.
Because the question has hence.
I think I like that statement. Kasule, go ahead. Kasule, can you hear us? Okay. Kasule may not be hearing us. Lynn says we don't.
She's
And
muted.
yes, please.
Kasule is muted.
Why?
Kasule is muted.
Why
She
is he
needs to
muted?
unmute.
Yes, muted. You can unmute. Okay. Kasule, we can't hear you. We can't get you. I don't know whether it's following us. It may not. Okay, you are there. You have unmuted. Please talk to us.
Master, you can't get the marks because the question has hence.
What is the meaning of hence? What is the meaning of?
You have to. If hence means you have to continue from where you stopped on the first question.
Thank you very much. Hence is please use your previous result. For me, in my simple language, please use your previous result. Now, if you do not have that previous result, you can't use it. That hence is telling us to use that previous result. If we do not have that previous result, we can't use it. So you will not get marks for using it if you don't get it. So the first thing that you have to struggle and do is to work out the first part. It is mandatory, it is a must before you start using it. Okay, thank you. I have seen Wambi and the others in the chat, Omogeni and Emuni. Okay, thank you. I get all that. Okay. If we do not have any other question, can I have, this could be our last. Why don't I scroll and get to, there's a question that I saw. Where did I see it? I saw this in Waukesha. I think I saw this in Waukesha. Where is the question? Am I okay? Thought I couldn't scroll. Oh. I think there was this, this was the first part, the 5 marks question, section A. And I think we can leave that one. Given the points P and Q, find the position vector of point R such that PR to PQ is 2 to 3. I want to think each one of us can do that. These are ordinary level questions, but the reason why I think I love the questions is because according to the abridged according to that curriculum, we should be able to answer these simple, this simple work. So that is why I have a big feeling that some of this work of this nature of the O-level thing in collinear, not collinear, etc., is more likely. We are more likely to have such work in our questions. So please put some emphasis on it, because that is what we have in our syllabus, the abridged one. Okay. So that is a question, which is that first part is almost entirely O-level work. Please make sure you put emphasis on it. Points A, B, C. Can someone read for us? Where is that someone ready to read for us?
A, B, C.
A, B, C, and C are non-collinear points with positions vectors A, B, and C respectively. Point P and Q are on BC and CA such that BP, BC equaling to 3 to 1. And collinear points are collinear points. Find in terms of A, B, and C the position vectors of P, Q, and R.
Thank you very much. Thank you very much. Let me write here. It's unfortunate I'm closing up the work, but Sama, your hand up. What is it?
Okay, can you scroll back up? I haven't seen that question. Like I haven't written it.
You don't have to write it. Take a screenshot. Please take a screenshot. I wanted just because I don't have where to write. I need where to write. It's a huge thing. And if I scroll, I close it. Okay, hoping you have taken the screenshot. Can I scroll? We shall keep scrolling up and down. You don't have to worry. But you can go to Waukesha 2022 and you will see this. Mr. Kaziba has endeavored to send us a number of question papers. Go through them and see your vector. Vector has one question in section A, and it also has one question in section B, and that's how the paper is set. One vector question in section A and one vector question in section B. And these are good marks to grab. Don't leave them, please. Go there and try your best to understand and interpret and then answer the question. What is this question telling us? It is giving us points A, B, and C. I can put my A there and my O there. The position vector of point A is that one. The position vector of point B is that one. And the position vector of point C is C. Now we are told that P is on BC, I think. Please forgive me for those drawings, but the idea is the most important thing. So I can go back and repeat that. P is a point on BC, did I get it? Point P and Q are on BC and CA. So P is on BC, Q is on CA. BP to PC is 3 to 1. BP, yeah? BP to PC. BP is 3 to 1 to PC. Now, what is the first question is saying, find in terms of ABC the position vectors of P, Q, and R. So first P, that one we can get. If we are told that B what? If we are told that this is our B, BP to PC is 3 to 1. Then it means that our total ratio, 3 plus 1 is the 4. And this tells us that therefore BP, vector BP, is 3/4 of vector BC. I want to think that everyone is there, and then we can go ahead and use that to get vector, the position vector of P, which is the OP. From BP, the definition of BP tells us that BP is OP minus OB. I want to think so. Can someone therefore give me what BC is? What is BC? What is BC by definition? We are running out of time, so I would want us to rush. It is OC.
Kamuli, Oli Awoli. Kama si.
OC minus OB. Thank you. Then what is OP? OP equals to OB when it crosses over, plus 3/4 of OC minus OB. Each one of us can work out this. I'm not going to wait for you. Sometimes you slow down, and I know you can. OB is B, then OC is C minus B. And when we simplify, it's going to be minus C to be B minus C 3/4 B. B minus 3/4 B is definitely 1/4 B. And then we are having 3/4 C. I can factorize out the 1/4, or I can put the LCM of 4. And when I factorize out the 1/4, I remain with the B, and I remain with 3C. That is OP. Please, you let me know. I'm moving a little fast here for 2 reasons. One, it is because we are moving against time. The second one is that this is something that I know you can follow. Kelly, Michael, I did not check in the chat on time, but I thank you for the contribution there. Someone's battery is, Emuni's battery is running low. Sorry about that. But we are also finishing. What I think is Mr. Kaziba will share the recording also to our WhatsApp chat, so you don't have to worry. Okay, then what else do I have? Can I look at Q? Q is a point on CA, and CQ to QA is 2 to 3. We can also look at that. Q is a point on CA, and the CQ is 2 to 3. I hope I'm picking the right thing. CA is this one here. Thank you. Then Q is somewhere. And the CQ to QA is 2 to 3. Am I picking the right thing? CQ to QA is 2 to 3. So there's no work here. It's the same thing. You are doing exactly what we have just done for the other. There's no work there. Please go ahead. What is OQ? It is OA plus AQ. And what is AQ? AQ is the 3 out of the total 5 of SC. If you want to use the root of OC to CQ, there's no problem. Either way, you get the route, each route leads you to the same answer. Oh, do I remember what route I'm taking? You can take OQ because we are looking for OQ. We are saying OQ is OA plus AQ. And we are saying OA is A, AQ is 3 out of the total. Total is 5 of SC. And what is SC? OC minus OA. And I've said I've just done in the previous example. So this is A plus 3/5 of C minus A. And when you simplify A and 3/5, A minus 3/5 A. What is A minus 3/5 A? It should be able to give us 2/5 A. Please follow it up and see. And then 3/5 C. And when I factorize out 1 out of 5, I can write 2A plus 3C. This is ordinary work. So this is exactly what we did even in the previous part where we were looking for Q. Which part am I interested in? Seriously, is the part of ARA. What does the question say about ARA? The question says that ARA is on BA produced. ARA is on BA produced. So it means that when you produce BA, what is the meaning of producing BA? You have BA and then you produce it. So it produces, it gives you ARA somewhere. I don't know exactly where. But what he continues to guide us with is that ARA is on BA produced. So BA, you produce it. It goes, BA continues. Such that PQ ARA are collinear. Such that P, Q, and R are collinear. So we have a straight line. We have a straight line. Sorry, I dropped off. Chris, can you give me back my powers? I hope I'm back. Chris, you have my powers, I think. Okay, I have my powers. Okay, thank you.
Please unmute.
Am I there now?
Yes.
Guys, can you hear me?
Saying anything? Yes, but
yes, Master, I can hear, but share the screen, please.
What is it?
Please share the screen. Share the screen.
My speaker, does it work now? Chris, you are the co-host. Can you talk to us? Chris?
Yeah, Master, everything's
Oh, something is wrong with my speaker.
Share the screen. Please share the screen.
You are not seeing, that's okay. I will share. I dropped off, but I can't hear. That is now the problem. I see as if you are hearing me. Your speaker is not working. Please check your connection or use a different speaker. I don't know what the speaker, what is wrong with my speaker now. Okay, let me check myself a little. I hope now I'm there. I'm sorry about that. I dropped off and it seems when I connected, I couldn't connect properly. Can I hear from you as we go on to wind up to see whether I can get you? I can see people here reacting.
Sir, we can hear you, but we can't see you on the screen.
Yeah, because it has, I am going to share again. I'm going to share. The screen is no problem. It was me. I couldn't hear you. Even when I talked, I could not get you. But I think now I can share. Oh, I'm not the host anymore. Can you, Chris, are you the host? Can you give me back the host powers? Chris?
Okay, sir. Okay, sir.
Can you give me back the host powers, please? Sorry about that. Can't share because I'm not a host. Now I'm going to share when I get back my powers. Don't worry. My network disturbed a little. As we complete this, I'm sorry about that. I think many people have dropped off, but no problem. Can we get there finally? Chris, tap on my name, and then you press more, and you see make a host, and you make host. Tap on my name, you see more, and you see make a host. Tap on more, and make a host. Chris, are you there? Chris? Chris, unmute and talk to me. I want to know what is not happening. Chris?
Yes, sir.
Tap on my name. Can you tap on my name? From participants. Yeah. Are you seeing the list of participants?
Yes, sir.
Tap on my name. Then, okay, you take this. Yeah, make host. I'm now the host. Good. And you still have your powers, your co-host. Now I can share. I'm sorry. I'm sorry about that. My network disappeared and I could not do anything. Couldn't help. Sorry about that. I wanted us to finish, but again, this one. Okay, I'm sharing. Are you seeing my screen again?
Yes, sir. Yes, sir.
Okay, let us be a little fast. I'm sorry about that network issues. And when I connected my mic or my whatever it was, I couldn't hear anything, even when I could talk as if you were hearing me, but I couldn't hear. And it was telling me here that I had issues with my mic. Okay, sorry about that. Let us try and run fast. Now I was talking about this ARA, which ARA is according to the work, which ARA is on BA produced. But again, BQ ARA is collinear, is a straight line. What is OARA? We are looking for OARA. So what is OARA? So can we look for this vector here, OARA? So from our work, I don't have near here where I can write because I don't want to rub what we have already discussed. So I'm going to scroll and hide it a little, but I can already say that what I want to write is that OARA is equal to, I can pass anywhere, but I want to use the OA plus ARA. I think that one is okay. Do you agree with me? Should I take that route, OA plus ARA?
Yes.
Okay. ORA is ORA. ORA is OA plus ARA. Now, OA is clear, that is A. What is not clear is the ARA. Go back to our figure and see what we should take ARA to be. ARA is not clear, we are not given the ratio. But even when we are not given the ratio, we are told that BA was produced. So we know very well that ARA and BA are parallel. ARA, you can write here. Let me use this one here. Okay, we know here that ARA, I was writing here, ARA and BA are parallel to BA. And we know very well that by parallelism, vectors, we mean that ARA can be written as a scalar product. Stable. ARA can be written as a scalar product of BA. Go ahead and that is ARA. ARA is some constant times BA. Now that constant, we don't know it. In the other cases, that constant has been there. They tell you the ratio is 3:2. But here we can go ahead and just say some constant ARA times BA. It is very important to take a note of the directions. You are seeing that my ARA is pointing downwards and my BA is also in the same direction. ARA and BA, both of them in that direction. Otherwise, if you take ARA and AB, then it means the K is a negative K. But here, we can maintain the same direction. What do we have? Then we have that. As we conclude, I want us to conclude. I'm very sorry. As we conclude, I can say that from the fact that they told us that PQ and R are collinear, it also means that they are in a straight line So in the same way, I can say PR is parallel to PQ. And if so, PR is some scalar. I don't know which other scalar I can use. Let me use lambda times PQ. I've used the K, but I can also use lambda. PR is some scalar lambda times PQ. So if I took that again, that PR is lambda times PQ, then you can go ahead and say PR is OR minus OP is lambda times PQ, which is also OQ minus OP. Please, you forgive me. So what is OR? I want us to stop. It is OP plus lambda into OQ minus OP. Please go ahead and follow up those smaller things. You will notice a few things. I don't know whether I have those. You will notice a few things. Let me see if I can get there. What are you going to notice? You will notice from this work that OR, after simplifying this, you're going to get 1/20 of 80 lambda A plus 5 into 1 minus lambda B plus 3 into 5 minus lambda into C. This will come from all of that. Remember, we know OQ and we know OP. Put them there. Even here, we know this other part. We know the BA. So we are going to have A plus K into BA, which is OA minus OB. And when you simplify, you are again going to get you're going to get A plus K. No. 1 plus K into A and then minus KB. And when you equate these two equations, because both of them are giving you OR, you will find out values of K and lambda. OR, which is 1 minus K plus K into A minus KB is 1/20. That is a long thing. I'm not going to rewrite it because I want us to wind up. Please forgive me. So when you equate the two vectors, the A's are equal. This A and this A are equal. So you will find that 1 plus KA, let me even write the A, is 8 lambda A out of 20, from which the A will go. You can simplify, divide by 4, simplify there, cross multiply. Go ahead, also equate the B's. Negative KB will be equal to the 5/20, 1 minus lambda, also B. Of course, the B's will go. You are also going to get an equation in what? In lambda and K. Also the C's. This side, there is no C, so it means the C is 0. The other side, it is 3, 5 minus lambda of the C equal to that 0. So that will, from this one, actually, you will get that lambda is 5. And when you get lambda is 5, you're also going to get k, and you will get that k is 1. If you put that 5 somewhere, you get that k is 1. So those are the values. And when you get them, it means you can go back, substitute, and get the OR, like here. After getting that the k is 1, the k is not a vector. So that thing which I've written there, k is not a vector, k is a scalar. So you are going to, this is not negative, it is not, there's no negative there. You are here, it's just 1 plus k into a. So when you put your k is 1, you are going to get 2a minus b. Was it a minus? I remember as if I got a plus. No, 2a minus b, it is true. 2a minus b for OR. So that is something I want you to follow up and see that you get those answers. I'm sorry for not giving you a chance to work with me, but I think I had tried out personally earlier. I looked at it. That is why I can easily say, please do that, okay? It would be good when you try out, you will enjoy it. It is using those facts where you are getting the OR in 2 different forms, and then you equate and get the scalars. Please do so. That is work that is yours. And this, and I love this number because I think this is similar to O-level work, a little harder, but I think this is what the abridged syllabus is all about. So I am looking at such questions have a higher chance of appearing. You'll also try out this part B, but part B is what we have tried out, I think, much more, because it is talking about plane and line, etc. That one you can continue and also do, no problem. Oh, I thank you. I want to thank you so much. I don't know whether Mr. Kaziba is back with us. Mr. Kaziba? Can you, Mr. Kaziba, if you are there, come and close for us? Okay, Mr. Kaziba is not here. He's not on the call. He has other calls he's also looking forward to. Okay, I have, if before we close, if you want to say something, please say it now, then we shall close. Bob.
Excuse me, sir. I was asking about, I got the lambda as 5, but the k, I'm not getting it as 1.
Yeah, try again, you are going to get it. You are going to get it.
Okay,
try again, you are going to get it.
Okay, sir.
I
thank
thank
you,
you
so much.
that you have already gotten the 5. Please check, you are going to get the 1. I don't know where you are losing it, but I have a feeling. I don't want to say I was the one who is very perfect, but I don't want to think that I made a mistake.
Master, hello?
Any other
hello?
word before we close?
Yes, sir.
Sir.
Yes, Andy?
Hello, Master.
Yes, Andy? Am I still connected? Someone was calling me and that could disconnect me.
Sir. Sir.
Yes, please.
I would like to help me with part B, maybe just giving a view of how I can go about it.
Part B you can handle. What is scaring you? I want us to close. I am seeing people have dropped off. I am seeing, I think this room is supposed to be used for another senior for discussion. Write down the equation of the line which passes through that one in the direction of this. Write down the equation. you are going to write maybe what I can say here. You are going to write the vector equation and then write the, when I'm told to write the equation, I write the what? The Cartesian. So you are going to write R equals to the point, which is 1, 0, negative 2 plus lambda into the direction. And the direction is given to us straight, 2, 3, 4. And find, then you will write the Cartesian. Our R is X, Y, Z, and you find lambda. What does this mean? It means plus 2 lambda, so that we can say lambda equals to X minus 1 over 2. Then we go ahead again. Y is 3 lambda plus 0, from which you can say lambda is Y minus Y over 3. And also Z is 4 lambda minus 2, from which we can say lambda is Z plus 2 over 4. Then you can write your Cartesian equation from there, equating the lambdas, X minus 1 over 2. Is X minus 1 over 2 equal to Y over 3 and equal to Z plus 2 over 4. This is the Cartesian equation, and that's what I would take for the equation. Then they say, and find the coordinates of the point where the line intersects. Where the two intersect, just solve simultaneously. In fact, it is easier to work with this for the intersection. What is X? X is 1 plus 2 lambda. Substitute it in there. So you are going to have 4 into 1 plus 2 lambda. Then plus 3y. What is the y? 3 lambda. Then plus the 2z. What is the z? It is 4 lambda minus 2. And this is equal to 25. Just forgive me for that caveat there, but I want us to end, I'm sorry. From that, you solve for lambda, and I think lambda is 1. I want to think lambda is 1. And you go back and substitute it here. X will be 1 plus 2 when lambda is 1. Y will be 3 times 1. Z will be, so you will get that the point, the position vector of the point is 3, 3, and 4 minus 2 is 2. And since they are saying the coordinates, you will finally give your answer. I feel bad the way I'm squeezing work here and disorganized. Please never be that, but I'm forced by conditions. I just want us to stop. So 3, 3, 2. That is, those are the points I want to think, because if I remember lambda, I think is 1. But you go through it and get your values and get those values properly and conclude your work. It is not going to be, you conclude your work, okay? For me, I'm just giving you an idea, follow it and do complete the work. That is a Waukesha question. Mr. Kaziba has already sent it on your WhatsApp group. You can always go there and find it there. Okay, I can see people have gone off. I wanted to hear from some school, which was somewhere. I think it dropped off. I'm sorry. But I want to thank my co-host, Chris. Chris, can you please open your mic? I want to thank
yes, sir.
Thank you so much for the controls, so that have enabled us to have a smooth lesson. Thank you. I want to thank everyone who is here.
You're welcome, sir. You're welcome, sir.
Good. I want to thank each one of you for logging on. That is 1. Then 2, for being there. I want to think each one of us has tried their level best. The questions are very many. Even mine, the ones that I had picked, I've just left them out. go and try out. Vector is something that each one of us can do and do very well. I appreciate those who appreciate. Those who appreciate, please, you are most welcome. Can we now have someone to close this with a prayer? Can we close with a prayer? I apologize for network. I can't do much. That's disturbance there, and for the time. I'm very sorry for that. I would have wished that we finish on time. But can we have a closing prayer? Someone, please? Yes,
okay, let me lead.
Ladu is there with a hand up.
All right, I'm going to close for us with a prayer. Let us humble ourselves. God Almighty Father, we want to thank you for all you've done for us. We want to thank you for all these good teachers who have, Father, that whatever we've done and good work, may all this believe in Jesus.
Amen. Thank you, Ladu. I got
That's mighty name. Amen.
Amen. I got a few issues with the network while you were praying, but I thank you very much. You can now open your mics. You can open your videos and say bye-bye. You can open your videos and say bye-bye. We want to see those guys. Bye-bye, Mainja. I can see your video.
Bye, sir. Thank you, sir.
It's a little dark. Bye-bye.
Thank you, sir. Bye.
Nice time, sir.